Okay, so on to question 7. Give the conjugate acid for each compound below. So conjugate acids are species that are formed after a base gains a proton. So let's just have an example of this. Okay, so let's say we had HCl plus water makes H3O plus Cl minus. So in this example, HCl is an acid. And we know this because it is the proton donor. So it gave one of its protons to the water. So water in this case is our base. And again, it is just our proton acceptor. So after the base gains the proton, it becomes H3O plus. And this is our example of the conjugate acid. And for chlorine, Cl minus, this is our conjugate base. So it is the species formed after the acid donates a proton. Okay, so now let's answer the question. So starting with compound A. So let's say this is our base. If it were to gain a proton, it becomes hydrogen sulfide. Okay, so that's the answer for A. HPO4 minus, or 2 minus, sorry. When it gains a proton, it becomes H2PO4 and then just minus 1. And then lastly, NH3, when it gains a proton, it becomes NH4 plus. Okay, so let's see what the junior tutor said. An extension of the Bronsted definition of acids and bases is the concept of conjugate acid-base pair. Recall that the Bronsted definition of acids and bases is about the ability of a substance to donate or accept a proton. A Bronsted acid is a substance that can donate a proton, while a Bronsted base is a substance that can accept a proton. Conjugate acid or conjugate base is then the species after the initial acid loses a proton or is the deprotonated acid. This follows that the conjugate acid is the species after the initial base gains a proton or is the protonated base. With that in mind, we can answer the question. Since we are given bases and are tasked to give the conjugate acids, what we have to do is to protonate all of the species. When HS- is protonated, we get hydrogen sulfide. Since we gave a proton, the sulfur will be bonded to 2 hydrogen atoms and will become neutrally charged. When we give a proton to HPO42-, the formed species is H2PO4-. The charge would increase by 1 since one of the oxygen atoms will now be bonded to the added hydrogen atom. Lastly, when we protonate NH3, the result is NH4+. Thus, the conjugate acids are H2S, H2PO4 minus, and NH4 plus. Yep, so this solution is correct.